Okay. Okay, yeah, with section 4B, we started doing compounding. So those examples were sort of like I'm throwing in money and I'm just falling asleep on it. So that's sort of why I had that Rip Van Winkle picture there. You don't touch the account. And these we start making payments, regular payments, some sort of payments. And so if you look at the formula sheet, we start introducing this variable called PMT. And so I believe most 4B was these three formulas. 4C is going to be the savings plan formulas, and then we're also going to do total and annual returns. Total returns really aren't anything new, they're just relative returns. Annual returns are a little bit weird. So the formulas definitely get a little bit larger for this section. All right. It's raining dogs over here. Planning for the future. I probably need to wake up. Any questions over what we did last time in 4B? Okay. So this section 4C, we're doing savings plan. So it is kind of similar. We put in money, we keep putting in money. Is the big difference here. We're making payments. So your goal is to create a college fund for your child. Suppose you find a fund that offers an APR of 5%. How much should you deposit monthly to accumulate 170K in 15 years? So if we're looking at the savings plan formula, you might notice there are two equations that they give you. This one is solved for what? The A, or the accumulated amount. So this one is solved for PMT, or the payment. So if they're asking for what is the final balance, what is the end balance, what is the accumulated amount, you're probably going to want to use this one over here, right? It's already solved for this one. We're just plugging in numbers over here and solving them. If we want to know what our payment is going to be, that's probably going to be this one right over here that we're going to want to use. And so they say, how much should you deposit monthly? That sounds like, oh, excuse me. That sounds like a payment that we're making in order to accumulate. So this is the accumulated amount. Okay. So these, in case you didn't notice, they're a little bit more complicated than what we were doing last time. There's a few more steps involved. All right. So I think what we're doing is solving for payment. I believe from the problem, my accumulated amount is the 170K that I want to find. My APR in this problem is what? 5%. N is the number of compounding, or the number of payments per year. So if you're doing things monthly, we talked about that. N should be 12. And I know I said there's two different formulas. They are really the same formula. If you look at them and try to solve one for the other, you will get the other formula. Basically, if you reciprocate this fraction and multiply it to the other side, you'll get this formula. And with most stuff in this section, if we're using the savings plan formula, I'm just going to round it to the nearest dollar. I think I'm getting what, 636 is what I'm getting, somewhere around there. Let's say 636. 712, that's close. That might be a rounding issue, so be careful. Okay, so this is the formula. We want to throw everything in there. Should be the next step. So 170K is my accumulated amount. 0.05 is my APR. 12 is my N. I throw everything in there. If you do this over and over again, you might notice some things repeating here. If we have APR over N here, we have APR over N here. It might help you kind of look things over. I think I divided what? 0.05 over 12. I divided 0.05 over 12 here, so it's like 0.00416 repeating. It's 1 in that here. It's just that by itself here. It's 1 in that decimal here. 12 and 15 make it 180, and the exponent. I multiply my top together, I'm going to get 708.33. I do this thing in the calculator, my exponents 1.00416 repeating to the 180 should give me like 2.11. I still have to subtract 1 from that and then divide that from 708. And that should give me something like 636. If they said to the nearest cent, I think I have to do 02. But around $636. Okay. The other thing, what might happen, maybe I'm wrong. You have to take this exponent before you do the subtraction, right? I think that might have been what you might have done. That would give you a little bit higher number than 708. So it is important you try these things. It's important you get down these order of operations in this section. So I think this is pretty similar. I think this is another savings account problem. At age 20, when you graduate, you start saving for retirement. If your investment plan pays an APR of 4.5% and you want to have 2.5 million when you retire in 45 years, how much should you deposit monthly? So they give us a lot of information. I know I read it pretty fast. But the question that they're asking is how much should you deposit monthly? And so hopefully you're looking at these equations, you're looking at this question. And if they're asking how much should they deposit monthly, are we looking for accumulated or payment? A monthly deposit sounds more like a payment than an end amount. So I think we're back to using this formula again. And probably going to go reread that problem to pick out all that information from there. So somewhere they're giving me an accumulated amount, an APR, an N, and a Y. So what do they say? At age 20, so I think that's a little bit of a red herring, probably, right? We don't really care what age you started. We just care how long you go. He's going for 45 years. Don't forget your money sign. 1242. Did I do that right? Let's see. I got 1432. I might put in the wrong thing in my yeah. Yeah, I think I put in the wrong thing. So let's go see. I'll write a note. 26 should be 1432. I think I might have messed up somewhere along here. So let's see. 0.04 divided by 12 times what, 2,500 or 2.5 million. Oh, 4.5 divided by 12. Okay, multiply that by 25. Should give me 93.75 on top. I'm going to do the same thing, 0.045. We're going to divide it by 12. It's going to be 0.00375. I'm going to add that to 1 and raise it by the 12 times 45. Let's subtract that by 1. So I should be getting 7.74. So those numbers look correct. So I must have done something right here with these numbers. So if I take 93.75 and I divide by that thing I just found, that should be 1431.85. So I don't know where that number is coming from. That's completely wrong. It should be 1431.85, so it should be 1432, somewhere in that ballpark. And that's why you show your work. And to be honest, like I really feel like everyone, like a lot of people want to know like what you should show. You should probably show me at least like this step where you plug everything in. Like I really feel like there should be at least probably this many steps in your work. If you're doing it in less steps, you're probably skipping stuff you really shouldn't skip or put down. Some kids not happy. Suppose you are 30 years old and would like to retire at 60, having accumulated a retirement fund from which you can draw an income of 100,000 per year forever. How much would you need to deposit each month to do this? Assume a constant APR of 6%. So they did something like this in the notes. This one is a little bit tricky. It is a homework problem, so I think they're allowed to be a little bit trickier. We want to have this as our income. We have an account that gives us 6% interest each year. And so what I believe they're doing is if you want to draw 100K per year, and you want to have this as a sort of like income, basically what they're kind of saying is you have some account and it's got like a buttload of money in it, basically. And this is the, what do I want to say? So we have 6% of some large amount. And that 6% is going to give us the 100K in interest. And so basically we're going to just have like, we're just going to be a millionaire, billionaire, whatever we have to be. So that 6% of whatever this large amount that we have is going to give us 100K off the interest. We can just continually take that interest off the top. We can just leave this large amount untouched. And we're just drawing this interest off of it each year. So 6% times this amount is going to give me 100K. How do I figure out the large amount that I need? I guess I could just call it the accumulated amount, I think, right? That's what it's going to be when I turn it around. I'm going to want to accumulate this amount so that I could just draw interest off of it. So I need to first figure out what my accumulated amount is that I want to end up at. And then after that, figure out 30 and retire by the age of 60. It sounds like what they're telling me is I have 30 years. It sounds like I'm probably going to compound things monthly or make monthly deposits each month. Right there, it says it there. If it doesn't say it, we're going to probably just assume they mean monthly with the deposits or with the payments. If you make deposits or payments, it's usually monthly. How much you need to deposit each month. So we want to know payment is what they're asking. And I think we have all the information we need to plug it into our payment formula and figure out what our payments would be. After we figure out the accumulated amount. Oh, I hope we got that right. No, that's way off. I think I got it wrong. Oh, I think I messed up on a decimal place somewhere in my stuff. It is easy to get these things wrong, and that is kind of like why I'm like saying it's really important to show work. Yeah, that sounds right. Which one am I? Very. Oh man. It should give you, I got it wrong on here, but it should give you, I got around 1659, I think is what I'm getting. Yeah, I got something way different. I don't know how I got my first thing. So definitely write your middle steps. I was just trying to throw everything in my calculator, if I'm being honest. And so this is what I was talking about. We want to do 6% of some sort of big amount. So this is the kind of the weird part in this problem, I feel like. If you understand that this is what you're doing, you're just skimming that money off of your interest each year, and you just have a buttload of money in your account, which is what, 1,666,000. So that is the accumulated amount I want to end with. I know I have 6% interest, doing things monthly for 30 years, filling in all that information into basically this. That's just the formula. If we crunch these numbers on top, it gives me somewhere around 8,333.33335. I look at the bottom, I divide these two, it's giving me 0.005. I add 1 to it, I get 1.005. I'm raising that to the 360 power. I'm doing this, I'm subtracting 1. It's going to give me 5.022 instead of 6.022. So I subtract 1 and then I divide them. I should be getting something around 1659. Okay. So I think if you got it wrong, I hope you realize why you're getting it wrong. If not, you can ask questions. But like I said, is like write your steps. There's a lot of processes or a lot of steps kind of involved in this thing. You should be writing probably at least as many as what I'm writing on here. And you should be checking, making sure you can do these sorts of things in your calculator. You're going to do exponents. I think one of the common mistakes is people will try to multiply instead of doing exponents. Oh, this is the total and annual returns. So going back to this, if we look at total returns, I think that's the first thing I ask you, but total returns are just your relative returns. It's the accumulated minus the principal over the principal. That's basically the new minus old over old. It's what you started with, right? Is the old. Annual returns a little bit different. It's accumulated over principal to the 1 over y. We've got to subtract 1. They are both percentages. And so I think this one is, first thing is the total return on this thing to 2 decimal places. It's a percentage to 2 decimal places. 5 years after buying 100 shares of XYZ stock for $60 per share, you sell them for $9,400. $9,400 is what you're selling them for in the end. That is your accumulated. What they don't give you here is your principal. So you might have to figure that thing out. But we know we got 100 shares for $60 each share. So we talked about unit analysis. That's probably easy enough to do even without doing a chapter on unit analysis. How much in shares would you have if you have 100 shares for $60 per share? So we're going from that amount to 9,400. Oh, man. It's not loading up right. Like this one should be super quick, I'm hoping. We've done, and we've done, and we've done, and we've done again, right? Relative differences. So we're going from what, 6,000 if you're doing 100 at 60 or 60 at 100. I believe we're doing what, $6,000 to 9,400. Doing the relative difference of that. Man. Who's going to be here? Come on, man. There we go. What was that give me? 56? Is that what I said? 56.67%. What else are y'all telling me? Y'all doing okay. Probably rushed to put something down. Put the so this is what I basically said. The new is the 94. The old is the 6,000. Doing the relative difference. I didn't put my multiply by 100. That's how lazy I was. This is 56.67%. It looks like we all got that. Something like that. And then now we want to do annual returns. Same account. Annual. And we talked about what the formula looks like. Same accumulated, same principal. Now when we talk about annual, we also have to talk about how long this thing went. So it went for 5 years. And in this example, we're going from 6,000 to 9,400. So it is going up. We are making money in this example. Hint and alluding, foreshadowing as to the next example, maybe. This one we're going up. Sometimes if you convert those exponents to like decimals, it might help you out. And this is going to give you something in a percentage. You have to, or it's a decimal. You have to convert this one to a percent. This one, it does tell you to convert to a percent. This one, it doesn't tell you to convert to a percent, but you really should. And you should round it to 2 decimal places. Ooh. Oh, there it goes. Okay. Oh, telling me 9.39, 9.4. Not sure where that 100's coming from. Okay, so we're doing annual returns. This is the formula for the annual returns. We are throwing things in there. So my accumulated amount is the 94. My principal is a 6,000. If I do 1/5 to my exponents, that might have been where you get that 100 from. Maybe, maybe not. If you do these exponents correctly, you have to be really careful with how you put this in your calculator if you're putting it into your calculator. Because you're doing this to the 1 divided by 5. It's probably going to raise all this. Your calculator is going to read it a little weird, right? If you don't put in parentheses around this exponent when you put it in your calculator, it's probably going to take this to the first power and then divide this by 5 is what your calculator is going to do. So you definitely want to put parentheses or do something and be very careful with these exponents that are fractional powers. I would even maybe convert them to decimal. It's usually easier to put into your calculator. This is a good even decimal. 1/5 is 0.2. So if we divide 9,400 by 6,000, raise it to the 0.2 power, I should be getting this number. So somehow you want to make sure you can get this number right here. Try to get that on your calculator somehow. Make sure you can do fractional exponents. And we take this and we subtract 1. That gives me 0.0939, somewhere in that ballpark, or 9.39%. Questions about this? Okay. Okay, so now what are we doing? I think we're doing the same thing with a different investment. We're going to do total returns and annual returns. 3 years after paying, this is what we start with, 3,500 for shares in the startup company. We're selling them at 2,000. And they say here it is at a loss. So they're trying to give you a hint of how this should go. You have to be sure you put things in the right order. It's new minus old over old. Make sure you're dividing by the old. And it should be a percentage to 2 decimal places. Maybe it the other way. Oh, have that one? Yeah. Oh, come on, relative difference. Here we go. Yeah, what'd y'all tell me? Did someone say 75? If you flip them, you get 75%, I think. Minus 42. Oh, just rounding. Okay. Yeah, y'all got it. So it is reversed. So this number has to be negative. I think we just got over stuff like this before when we did relative difference. Or it goes down. So it can be negative. If your total return is negative, what do you think that means about your annual return? If overall it's going down, if we look at smaller segments, is it also going up or down? So 3 years, they're giving us, remember this is my accumulated, this is my principal, and I'm going for 3 years. I think that's all the information you need to plug it in. Multiply by 100 to convert it to percentage. Round it to 2 decimal places. Those noises are kind of annoying. Oh, shoot. I forgot my percent sign, so don't do that. Right here. Oh, yeah, I got 1% sign. Oh, it tells you what the solution is, huh? Well, it looks like y'all all put your percent signs. So going on over the annual return, that's a formula that hopefully it looks like you plugged it into. We should be getting that number to that number. And then we subtract 1. It should give me a negative 17.02%. Okay, so now we're answering questions about the stock market. Oh man, this should take you 3 seconds. What is the symbol for the stock or whatever the heck that says? What is the symbol for the Intel stock? Oh, hold on. I gotta type it in. Not too fast. Okay. INTC. That's it. Look at there. The next thing is what was the price on the previous day? So we know the price today is the amount that it says last. And we know the change from the previous day was going up 24. So how much was it on the previous day? Oh God, did I put it on? Yeah. I hope I put a money sign in there. This was the change from the previous day. This is the amount that we're at now. So if it did this to get here, how do we go backwards? How do you undo a pluses? Oh, come on. We're doing 35.48 and we're subtracting 24 cents, right? Hopefully. Oh, come on, come on, come on. 35.24, there we go. Taking the last, subtracting the change. Next question is, excuse me. Based on the current price, what is the total value of the shares that have been traded so far today? So this is the amount of shares that have been traded. These are the total shares for the company. So I did go over in the notes like what each of these little things means in here. But this is the current price. This is the price they want you to go by. This is the number of shares that have been traded. And so I think I even said maybe round it. What did I say? Round it to the. No, you can give me exact amount. To the nearest dollar, I think, is what you can do. It should give you a sort of exact amount. Okay, there we go. And so, yeah, I'm multiplying those two to find how much worth in shares you've traded today. So now what are we looking for? What percentage of all Intel shares have been traded so far today? So I think I went over that. These are the number of shares that have been traded so far today. We want to know what percentage that is of all the shares. You might want to note that is in, this one is in millions. This one is in just what it's in. So millions, I think what that tells me is to add what, 6 zeros on the end of that. 2, 3, 4, 5, 6. And I want a percentage to 2 decimal places. Oh man. Do y'all drink coffee? Man, you're supposed to divide 2 numbers and multiply by 100 here. I don't know. I'd like to. Ooh, come on, man. Yeah, we got slides to go through, man. I'm just like, I don't understand people's approach to this class. It's baffling me. Okay. It's like I lay out the amount of work that needs to be done. It's like, this is the work we got to do. And it's like, y'all just drudge it long. It's just like, this could be like so much easier. It's like, you make things more difficult on yourself, and it just doesn't make sense to me. It's your class. I don't want to tell you. It's pretty noticeable, though. It's like, when people work with me, then it's what are y'all saying? 22? No. What are y'all doing? That's 0.22. What are y'all multiplying by? 0.2 is close, yeah. We're dividing those two numbers. It should be 0.00222. We only move it 2 decimal places. Okay. It is not very much. We're trading what, 10 million out of 407 out of 4 billion. It's not going to be very much. Almost 5 billion. It's going to be a fraction of a percent. And this one says, suppose you own 100 shares of Intel stock. Based on the current price and dividend yield, what total dividend should you expect to receive this year? We have this many. We have 100 shares of this price. And I know I'm going to receive 3% dividend for whatever I have, my total value of shares. So if I have 100 shares at this price, the first thing I have to do is maybe find the value of all my shares. And then I have to find out what 3% of that is. Or 3.07, I guess, or whatever it is. And round that to the nearest cent, I believe is what I have. Like 92, what else are we saying? Yeah, I'm not sure of that. It's a little high. Okay, so we're doing 100 shares for 35.48 per share. We should have 35.48 total in stocks. If we want to do 3% of that, multiply by 0.0307 by the 35.48, we should be getting 108.92. Okay. What were the earnings per share for Intel? So we are assuming things are the current price, which is 35.48. If we want to know earnings, they don't give earnings straight off. They give price to earnings. So if you want to write P divided by E is equal to 15.4. We know our price is 35.48. We can fill that in for our P. Then we have to figure out what E is. So we do have to do a little bit of solving to figure it out. not the most complicated thing, but it was a little bit of work. And this should be a dollar amount. So you're going to round it to the nearest cent. I think we got one more question after this with the with this chart. So if this is P divided by E equals this, is that what it said? Did you change? Oh, I don't know what, like, their student count is always weird on these things. P divided by E equals 15.4. So I think I'm saying what? 35.48 divided by E should give me 15.4. How do we figure out that other number? I'll give you all 30 seconds. Okay. Tell me 230. Yeah, you still probably. I see what you did. Okay. So 35.48 P divided by E is 15.4. So this is what I was saying. 35.48 divided by P is 15.4. There are a few ways to do this. I guess you could put this thing over 1 and like cross multiply if you wanted. But if you know, like, division is two things being multiplied, we multiply by these two things to get to this thing. There's a little bit of a gimmick. You can swap your, what order they would be, factors around, right, to get to the product. So if we're dividing by P to get here, we can divide by the other number to get to P. That's one way to do it. There are several others. So this I think comes up again. But that's going to give you $2.30 for each share. So that's the amount that they're going to earn per share. Now, how much are they going to earn total? What was their total profit? So if they're earning $2.30 per share, and this is all the numbers of shares, what is the total profit? And I think I said round to the nearest million. So there should be like 6 zeros, I think is what that says. I think I did an exact amount too. Shoot, was it? It was $2.30, right? Is that what it was? Yeah, that's it. We'll put that money sign first. 30. Okay. Yeah, it should be 10 billion. What are you telling me? 10 billion? As long as you're getting something around 10 billion, I think you'd be pretty safe. Why does it not scroll up and down when I do this? It's got to be like lagging or something. There we go. Now it's giving me a scroll bar. 10 should be 10 billion. That looks correct. It looks like you missed a zero here. Should I think have one more zero here? Okay. And 2.3 per share, and multiply that by the 4 billion shares that they have. My calculator spits me out something that looks like 1.0830. It should say 7 there. I don't know why it says 1. E to the 10. So what that tells me is I have to move 10 spaces. So this is giving me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to add 5 zeros there after the 7, I think is what that's telling me. That is the total amount. I think it's the final one for the stock. So this one is really similar to the price per earnings in the previous one for that stock problem. If IBM closes at 151.98 per share with the price earning ratio of 12.49, find the earnings. To the nearest dollar, I believe. So P divided by E is this, and this is my P. What is my E? Oh, it's lagging. Oh man, it's getting tired of me being on here. It's telling me hurry up. Okay. Okay, this is what we did already. This is that thing with the quotients and the products. We divide one by the other. What are we getting? 12. Did I get 1216? Is that what I got? 1217? What are you telling me? 1217? 1216? Yeah, that's it. Did it count me wrong for not rounding it up or something? That's probably what it did. Okay, so then, and then the second part of this question says, does the stock seem overpriced, underpriced, priced about right? If the typical P to E ratios range from 12 to 14. And so hopefully, I think we're at 12.49. That is within the range. Sorry, I have silly responses. But yeah, the porridge is just right there. There you go. We're going to play Goldilocks for a second. Oh, lost connection. Okay, next slide. Come on. Mutual funds. Now we're looking at this mutual fund. And we're looking at this thing. Suppose you invest $5,000 in the fund. How many shares can you buy? So you got $5,000. We know this mutual fund is going for what? 1099. How many shares is that going to buy you? You want to round that to 2 decimal places. Apparently, they're doing fractional shares. You can do fractional shares. It just depends upon the company and who's your trader. So that is a thing that does happen. Although the book does something weird, I'm not sure I would have done it. We'll talk about it in a second, I guess. And this is the number of shares, so don't put in any kind of units. It should just be straightforward. How many of these can you buy with $5,000? Oh, what am I doing? Okay, we got to get through these. Yeah, we got to be active in class, man. Like, it's like, come on, man. Like, dividing 2 numbers, it should take you 30 seconds to hit that. I mean, I got to come to class, but I'm preaching to the choir on that one. So I guess the other ones will have to figure out through their grade. Like, I literally have 2 ways to talk to you through as an instructor. One of them is verbally, or sort of in writing or verbally, or through your grade. So if so divide the 2, figure out how many shares you can buy. Okay, now they're wanting to know if we invested what 5,000 5 years ago, how much would your investment be worth now? And my sort of hint is that when you figure this out, it is similar to sort of compounding interest. So we're looking at a compound interest with an APR rate of 1.25, and you figure it just kind of like it's annually compounded. You figure it kind of like that, like the annual compounding formula. Compounded once per year, something like that, at a rate of 1.25. And we're going for 5 years, starting with $5,000. Is that what I said? Yeah. And I believe this is also rounded to the nearest cent. And the good thing about this is oh yeah, I got it. Okay. 53, 20, 41. That's it. So we're filling this in like it's compounded once per year. So it's the $5,000. If we convert that 1.25%, it's 0.0125. The number of years that we're going is 5 years, 53, 20, 41. We're going to do the same thing for 10 years. So look at this, think about what's going to change. Probably that 5 there, and my APR is going to change to 2.45. And I believe that's the next problem, is what's going to happen if we do the same thing over 10 years. Let's double check. Suppose we have 5,000 in this fund and we do it for 10 years. Okay. What are y'all getting here? 63, 69, somewhere in that ballpark, hopefully. Here we go. 63, 69, 27. That's it. So like I said, we're just changing this percent. We're changing the nearest to 10. We get a different number. And Mitch and Bill. So this one has a few steps to it. Getting started early. So Mitch and Bill are both age 75. Mitch was 25 years old when he started depositing $1,000 per year. He got broke and couldn't keep doing that, so he deposited that for what, 10 years? And well, I scrolled up and down. He made deposits for the first 10 years, at which point he couldn't make them anymore. And so he just left the money there and it continued to earn interest for 40 years. Bill was late to the game. He didn't start saving until he was 45, but he saved for 30 years and made annual deposits of $1,000. Assume that both accounts earned an average annual return of 5%, compounded once per year, which makes things really kind of nice. How much money did Mitch have in his account at 75? So going and looking at Mitch started when he was 25. So I think what we have to do is he was doing a savings account. He was putting $1,000 per year into a savings account for 10 years. I think we're going to have to figure out how much money he made doing that using the savings plan formula. And then after that, he just left money there. So this sounds more like a Rip Van Winkle sort of problem. So we're going to take that money that he gets from the savings account and we're going to Rip Van Winkle it for 40 years, if that makes sense. Compound it for 40 years. Do the one without the payment for 40 years. But first, we got to find the savings plan. So he did a savings plan, $1,000 payments for 10 years. And what else? 5% APR compounded once per year. So we want to figure out that savings plan. I think so far we've just been using this one on the right. Now, which one do we want to use? Well, they're giving us payments. I think we want to figure out accumulated amount. Was it 5%? Okay. So 5% compounded once per year. And I believe this is just to the nearest whole dollar. And this one is pretty involved. It is a homework problem, definitely.
Oh, Professor.
Yeah, what's up?
So what do we do? After we find his savings account, what do we do? The compound interest?
Yeah, so you're basically gonna like, I think it's this one basically, right? You're plugging it in compounded once per year for 40 years. So you're taking that principal, he's taking that money that he took from the savings account and just basically throwing it into like a sort of compounding account. He's not making payments anymore. So we got to kind of plug it into this guy. You take the accumulated amount from the savings, becomes your principal here. Your APR is still, is it 5%? Was that what it was in this problem? Or is it? Double check. I think it's 5. The number of years is 40. Oh, I can't scroll because I did it. Yeah, it's 5%. Did you get like 12,577 out of that savings? I think that's what I've got. If I did it right. I take that amount. That seems wrong. Uh,
Wait, so do we run to the nearest whole dollar or cents?
the nearest whole dollar on this one is good enough since we're using this big crazy formula. $1,000. What are we getting? 88, 548, 29. Woo, where are we at? uh 10 years in savings account and 40 years compound interest. So this is the savings account. We hadn't used this formula yet, but it is basically the same formula with this fraction flipped. So I'm plugging in $1,000 for my payment. I'm plugging in 0.05. Dividing by 1 is not really doing anything. Multiplying by 1 here isn't really doing anything. So I think I clean this up a little bit. Just the dividing by 1 and multiplying by 1 thing. So basically I'm taking 1.05, I'm raising it to the 10th, subtracting 1 on top. Then I'm dividing that by 0.5 to get to this number, 12.57. And get out of here. That should give me somewhere around 12,577. Did y'all get that far?
Yeah, I just put the wrong exponent and the wrong year.
The wrong number of years. Is that what it was? Yeah, this problem is a little bit confusing. It's got a little bit of process to it, but it's doable. Ooh. Okay. And we take that number, that's like our principal in another account that is earning the same 5% interest, and we're going for 40 years in that account. Okay. This next one is a little bit easier. I think we're just doing one savings account for, who is it, Bill? Mitch and Bill. Bill didn't start saving until he was 45. For the next 30 years, he made annual deposits of $1,000. So we're basically doing a savings account for 30 years, $1,000, 5% interest compounded once per year. It should look very similar to the savings account we set up before, but now we're going for 30 years. That's not what I meant to do. Are we answering this? This one shouldn't take that long. Like you did the other one or set it up. I think the only thing we're really changing here is it's going from 10 years to 30 years. Everything else should be the same. So basically, we're comparing someone that did a savings account for 10 years and then just fell asleep for 40 years versus someone that did what, a savings account for 30 years. I mean, if y'all want to spend longer on these problems, we can. It's like, I don't know, man. I don't know. What are y'all telling me? 66,439. Woo! Yeah. Okay. Nearest dollar. So I think y'all are getting it. 2 of you are getting it. But we're doing it for 30 years. So that is the formula. So it looks very similar to the previous one, but I think the only thing that changes is my years is 30. So 1.05 to the 30, I subtract 1, I divide by 0.05, and I multiply it by 1,000. I should be getting something around 66,439. Okay. And now this thing should hopefully take us a few seconds. But if Mitch is depositing $1,000 and he's depositing $1,000 for 10 years, how much money did he deposit? Depositing $1,000 per year for 10 years. This is hopefully one of those ones that takes you 10 seconds. It takes you longer to type it than it does to think about it, hopefully. If you're depositing $1,000 10 times, you're going to have, oh man, if this takes you longer than 10 seconds, I'm going to cry. Oh, man, where at? What are y'all doing, man? What's 10 times 1,000? I'm not trying to spend all day doing this homework. What are we doing? Oh, it is not. Maybe y'all did answer. I hope. Oh, man, what are you doing? Spending way too long on this problem. 10 times 10, if you're depositing $1,000 10 times, it's going to be $10,000. And if you deposit $1,000 over what? 30 years? Is that what this one was now? How much are you spending there? It's going to take me more time to load this stupid page than it is to answer. Okay, 30,000. And now they want you to like kind of compare and contrast these things. So go back, look at those amounts. I believe Mitch made more than Bill did. And so what did Mitch do? He put his money, he did a savings account for 10. So he did only spend 1/3 of what Bill did, but he ends up with more money. And why does he end up with more money? He doesn't have a savings account for as long as Bill has. But he does put it aside, right? So if you start saving, I think the thing that they're trying to get at here is the earlier you're saving, sort of the better off you are. So write a paragraph. So in this paragraph, you should contain how much did each of them deposit, right? That should be in this paragraph. Within the paragraph, you should say how much each one of them made. You should say what your kind of inference is on that. Why is Mitch making more than Bill? Bill did have an account, a savings account for longer where he was making payments, but it turns out time is a sort of larger factor there. Okay, so I kind of touched on what I'm kind of expecting. I don't really expect you to type that all out in here, but definitely be sure to do that. Write me a paragraph explaining things a little bit like I just did verbally, but do it legibly written. Choose one of the 30 companies in the Dow Jones. Okay, so this is the final problem that they assigned you, but this is something you have to go do on your own. Try to find as much of this information as possible. I know they don't just have all this readily available, so if you can't find like one or two of these things, that's okay. Like I really want you to go look at a stock ticker. I want you to kind of look at what these stock tickers look like when you go look at them in reality. Any questions? That's the final thing I got for you today. Okay, so that is it. I'm going to end this. If you got any questions, I will be here. Yeah, end this. Stop sharing.